Tonight, I just wanna take you out.
Hi, um, we're gonna make a circuit to prove that if things it is an insulator or a conductor. So what we need to use for this circuit is the following things: battery, um, just a little bulb, and cables. So after we have the circuit built and everything working, we're gonna prove it with things if there are a conductor or an insulator. If the LED turns on, it means it's a conductor. If it doesn't turn on, it means it's an insulator. We have four things that we're gonna prove. It's a piece of aluminum, piece of carton, knife, and a pencil. We're gonna start with the piece of aluminum. We're gonna take the little things we have here. Oh, and instantly it turns on, so it's a conductor. Piece of carton. We're gonna try. And it doesn't turn on, so it's an insulator. The knife. It's a conductor, and apparently it's good because it turns on and the light is so hard, so it's a good one. And with the pencil that it's made of wood, it doesn't turn on, so it's an insulator. The aluminum is a conductor, carton is an insulator, the knife made of metal is a conductor, and the wood is an insulator. The pencil.
Hello, my name is Alejandro Alfaro, and I'm going to talk about how the electric energy flows. The electric field that is applied to the wire causes the electrons that are inside the wire to move. This movement involves the friction, so it's like electrical resistance, which in turn causes the heat. It causes an emission and photons. The important thing is that it is not the field that is flowing. The field causes a flow, and that flow causes the heat. We are going to see how an example of an electric flux. This is a simple circuit with a battery of a switch and a light bulb. The battery has the energy in a chemical form. There are atoms and molecules separated into ions that generate the voltage drop. Across the switch, not current flows as long as the switch is open and no energy is transferred. Once the switch is closed, a current develops in the wires. Electrons in the conduction band move through the wires from the positive to the negative pole through the light bulb. The electrons have an average drift velocity carrying kinetic energy. In the wire itself, they do not lose energy. In the resistance of the lamp, they lose energy transferring into the molecules of the resistor. The way electrons lose energy when declared is through photons. In the case of the light bulb, infrared photons which make the lamp incandescent and then excites the electrons of the molecules of the resistor to high levels, enough to start at the existing invisible light photon transitions.
An insulator is a material that doesn't allow charges to flow easily through the material. Also, this one have a low conductivity. This happens because the insulators have a few free electrons and does not transfer electrical energy as well. An example of this one is wood, rubber, glass, ceramic, and plastic. We use this to cover conductor material. Like in this example, we use the insulator to cover it for electrical charge.
So in the experiment there are some type of materials that do not conduct the electricity. These are called the insulator materials. And these are materials that prevent the passage of the electricity. This can be possible because this type of materials do not conduct the electricity. it rejects the flow of the current. So in an insulator material, the charge have difficult to mobilizing through them. And in an electric circuit, if we put an insulator material, the energy can't flow from one side to the other side. Therefore, the circuit will not be complete.